A gender selection technique is designed to increase the likelihood that a baby will be a girl. In the results of the gender selection technique, 785 births consisted of 384 baby girls and 401 baby boys. In analyzing these results, assume that boys and girls are equally likely. Part A says find the probability of getting exactly 384 girls and 785 births. Now the first step is we want to be able to identify the values of n, p, and q. So we know that the sample size n is 785, and the probability of getting a girl is 0.5, and the complement of that is 1 minus 0.5 is 0.5. Now we want to be able to calculate the values of n times p and n times q. Well, n times p needs to be greater than or equal to 5, and n times q has to be greater than or equal to 5. So n, which is 785 times 0.5, gives us 392.5, which is greater than 5. 785 times 0.5 is 392.5, which also is greater than 5. So the normal distribution can be used to approximate this discrete probability because both of those are greater than or equal to 5. Now we want to be able to find the mean and the standard deviation. The mean is equal to n times p, which we've already found here. So 785 times 0.5 is 392.5. And the standard deviation is the square root of 785 times 0.5 times 0.5, which is equal to the square root of 196.25. And rounding it to 6 decimal places gives us a standard deviation of 14.008925. Now in step 4, we want to draw a normal distribution centered about the mean, which is 392.5, and then draw a vertical strip area, which is centered over x equals 384. And since it is exactly 384, we're going to include 384 and shade between the continuity correction. So let's go ahead and draw our bell curve. So we're drawing our bell curve. Okay, we know that the mean is 392.5. And the value of x is 384, so it's to the left of that. And so, since we know it's exactly, it's got to be in between those values. So it's going to be 384 has to be in between the continuity correction. So the continuity correction represents the discrete whole number x by the interval of x minus 0.5 to x plus 0.5. So if we take 384 and subtract 0.5, we get 383.5. And then 384 plus 0.5 gives us 384.5. And so what we want to be able to do then is, again, since it's exactly, we want to shade in between those values. So let's shade in between to find that probability. And that is the area that we're looking for, and therefore it's going to contain 384. Okay, now the next step we're going to do is we want to be able to then convert these two values of the continuity correction into z-scores. So we know that the mean is going to be 0. We know that we're going to have a z-score for 383.5, and then we're going to have a z-score for 384.5. So recall that the mean is 392.5 and the standard deviation is 14.008925. So to find the z-score for 383.5, you take 383.5, subtract the mean of 392.5, and divide by the standard deviation of 14.008925, and that gives us negative 0.642447. Rounding that to 2 decimal places gives us negative 0.64. So therefore this verse z-score is negative 0.64. Okay, and then the second z-score, we're looking at 384.5 minus 392.5 divided by 14.008925, and that gives us negative 0.571064. And again, rounding that to 2 decimal places gives us negative 0.57. So therefore, we have negative 0.57. So now what we're going to do is we're going to use StatCrunch to find the area that's in between those two z-scores. So in order to do that, we want to make sure we go to Stat, select Calculators, and then go to Normal. Since we're looking for in between, we want to select between. We have our lower value of negative 0.64, and the upper value is going to be negative 0.57, and then select Compute, and therefore that's going to give us our area or our probability. So we would say that the region in the graph rounded to 4 decimal places is going to be 0.0233. Hence, there is a 0.0233 probability that among the 785 births, exactly 384 of them will be girls. Okay, now in part B it says find the probability of getting 384 or more girls in 785 births. If boys and girls are equally likely, is 384 girls and 785 births unusually high? So remember that the mean is 392.5, and so we're going to draw a normal curve that's centered around that. So let's first do that. We have our bell curve. Again, we know the mean is 392.5. Okay, now it says since it is 384 or more. Well, 384 or more is the same thing as at least 384. Now, if we look at the chart, at least means that you include 150, the value and above. So we're going to include 384 and shade to the right of the continuity correction. So we're going to first write down where 384 is. So there's 384 on our bell curve. Okay, and now we're going to go ahead and do the continuity correction. So remember, the continuity correction is going to be now 384 minus 0.5 because we need to include 384. So therefore, we're going to draw this value here, which is going to represent 383.5. And so therefore, if we take a look at the z-scale, we know that this is 0. Now we've already found that z-score, which was z-score 1, up here in part A, and that was negative 0.64. Okay, and then because it's saying that it is or more, or meaning at least, that means we need to shade and find the area to the right of that value. So let's go ahead and shade to the right. Okay, so now that we have that z-score, now we can go ahead and plug it into StatCrunch. So now that you have your calculator, just make sure you select options and select refresh. And the mean is 0, the standard deviation is 1, and now we want to change this to be greater than or equal to the value of negative 0.64, and that's going to give us our probability. And so therefore, rounding it to 4 decimal places, we get 0.7389. So there is a 0.7389 probability that among the 785 births, 384 or more of them will be girls. Now, to determine whether a result is significantly or unusually high, note that X successes among N trials is a significantly high number of successes if the probability of X or more successes is unlikely with a probability of 0.05 or less. That is, x is a significantly high number of successes if that probability of x or more is less than or equal to 0.05. Well, we found that probability to be 0.7389, and it's greater than 0.05. So therefore, we would say no, because 384 girls and 785 births is not far from what is expected, given that the probability of having a girl or a boy. Now in part C, it says, which probability is relevant for trying to determine whether the technique is effective, the result from part A or the result from part B? Now, to determine what the goal is for determining if the gender selection technique is effective, also consider if the case where the gender selection technique is more effective than anticipated also fulfills this goal. The result from part B is more relevant because one wants the probability of a result that is at least as extreme as the one obtained. In part D, based on the results, does it appear that the gender selection technique is effective? Well, we would use the relevant probability for trying to determine whether the technique is effective. And note that an event is unlikely if its probability of 0.05 or less. If an event is unlikely, then that means the event is not attributable to random chance. So we would say no, because the probability of having 384 or more girls and 785 births is not unlikely, and thus it is attributable to random chance.